In the present video, we will discuss the GATE previous questions in line balancing. Let's see the first question. The table gives details of an assembly line. In the table, there are given the different workstations along with the total task time at the workstation. What is the line efficiency of the assembly line? Option A 70%, option B 75%, option C 80%, option D 85%. This question is given in GATE 2006 for mechanical paper. Let's see the solution. Here I have to determine the line efficiency. We know the formula for the line efficiency, that is line efficiency equal to sum of task times divided by actual number of workstations into workstation cycle time. So here I have to determine the task times, total task times or sum of the task times and number of workstations and the cycle time. So first we will look for the sum of task times. So there are the different workstations are given and also given the task time. Then the sum of these task times will become the 7 plus and 9 plus 7 plus 10 plus 9 plus 6, which is equal to the 48 minutes. So next we have to look for the number of workstations. So in the problem itself it is given the workstations are the 6. So total number of workstations are the 6. Next we have to look for the workstation cycle time. So workstation cycle time equal to the total availability time divided by number of units produced. But in the data it is not given, but we know that cycle time is the maximum time available at each workstation to complete its task so that the line will be flow smoothly. Then cycle time equal to the maximum workstation time. Here there are given the 6 workstations along with the total task time. So here maximum task time for the fourth workstation. So maximum workstation time is the 10 minutes. So cycle time equal to the maximum workstation time equal to 10 minutes. Now we know the sum of task times and number of workstations and cycle time. Then substitute in the efficiency formula. Then 48 divided by 6 into 10, which is equal to 48 by 60. So which is the 6 8 ja and 6 10. So it will be 80%. So then option C is the correct answer. Let's see the second problem. An electronic equipment manufacturer has decided to add a component subassembly operation that can produce 80 units during a regular 8-hour shift. This operation consists of 3 activities as below. Activity M, mechanical assembly, and standard time is 12 minutes. Activity E, electric wiring, standard time is 16 minutes. And activity T, test, so having the standard time is the 3 minutes. For line balancing, the number of workstations required for the activities M, E and T would respectively. Option A 231, option B 321, option C 242, option D 213. So here I have to determine the number of workstation at respected activities M, E and T. So let's consider each activity is one workstation. So first I have to observe the given data. So here given data is the produce 80 units. So number of units to be produced is 80 and the total availability time is 8 hours per shift. So total availability time per shift equal to the 8 hours. So next we have to determine the number of workstations at the respected activities. We know that number of workstations, so n equal to sum of task times divided by cycle time. So here first we have to determine the cycle time. So cycle time C equal to production time divided by required output. Here production time is the 8 hours, but here all the activities are in the time is the minutes. So better have to convert this into minutes, that is the 8 into 60. So that is the 480 minutes. Then cycle time will become the, so production time, that is 8 into 60 divided by required output is the 80. Then C equal to 60 by 10, which is equal to the 6. Then we determine the workstations required for the different activities. So first we have to determine the number of workstations for the activity M. So there is the task time is at the activity M 12 minutes. So number of workstation at the activity M will become the task time is the 12 divided by cycle time is the 6. Then 12 by 6, which is equal to the 2. Similarly at activity E, number of workstation will become the, so task time is the 16 and cycle time is the 6. So 16 by 6, which is equal to the 2.67, which is nearly 3. So next we have to look for the activity T. Sorry, here activity T. For activity T, number of workstation will become the, so task time, that is the 3 minutes divided by cycle time, that is the 6. So 3 by 6, which is equal to the 0.5, nearly 1. So number of workstations at M is the 2 and at E it is the 3 and T it is the 1. So option is A is the correct answer, 2, 3, 1. Next we look for the another question. In an assembly line for assembling toys, 5 workers are assigned the task which take times of 10, 8, 6, 9 and 10 minutes respectively. The balance delay for the line is option A 43.3%, option B 14.8%, option C 14%, option D 16.3%. So let's see the solution, and this question is given in the GATE 1996 for the mechanical paper, and moreover this question is given in UPSC exam in 2017. So let's see the solution. So in the introduction we discussed balance delay is the percentage of ideal time in the system, and the formula is balance delay equal to 1 minus efficiency. So first we will determine the efficiency. We know efficiency equal to the sum of task times divided by actual number of workstations into workstation cycle time. So here we have to consider task times. Let's consider each worker as each workstation. Then sum of task times will become the 10 plus 8 plus 6 plus 9 plus 10. And actual number of workstations are the 5 workers. Let's consider the number of workstations is the 5. And workstation cycle time. So workstation cycle time is the, so maximum task time at the respected workstation. So let's see the determination of efficiency. So here sum of task times equal to 10 plus 8 plus 6 plus 9 plus 10, which is equal to 43 minutes. And actual number of workstations are the, so let's consider number of workers are the 5. Similarly, have to consider number of workstations are the 5. And workstation cycle time. So cycle time is the maximum time available at each workstation to complete its task. So here maximum time is the 10 minutes. So let's consider the cycle time is the 10 minutes. So here we know the task times and number of workstations and the cycle time, and substitute all these values in the efficiency formula. Then efficiency equal to 43 divided by 5 into 10, which is equal to the 0.86, which is the 86%. But we have to determine the balance delay. Balance delay is the 1 minus efficiency. So that is 1 minus 0.86, which is equal to the 0.14, which means 14%. So option C is the correct answer. So these are the GATE previous questions for the line balancing topic. Thank you.